welcome to the webinar, How to Secure ICS OT IoT Environments with Cisco Cyber Vision. My name is Danijel Grah and I will be your host today. In the name of the company NIL, that is part of the Conster Group, I would like to thank you for all attending this webinar. We are organizing this event together with our other companies from the Conster Group, so a special welcome also to our guests from Denmark, Netherlands, Norway, and Sweden. As I already said, my name is Danijel Grah, and I work as a cybersecurity analyst at NIL Security Operations Center. Before joining the NIL team, I worked for about 7 years as a pen tester, and I did all kinds of interesting projects where I saw many, let's say, interesting security issues and also human error. I did also some bug bounty at free time, but I'm not doing this anymore since I try to balance my professional life with sports and other activities. Lately, I gained interest into ICS security, and of course, in NIL Security Operations Center, I focus also on operations and research. So this is me. NIL, the company I work for, provides advanced IT solutions, services, consulting, and training around the globe. Our headquarters are in Slovenia, but we have representatives across Europe, Middle East, and Africa, as well as in Canada. And because today we will talk about Cisco Cyber Vision, it is important to mention that Cisco has been our strategic technology partner for over 20 years, and the company holds several Cisco partner designations. As I already said, since 2019, NIL is part of the Conster Group. Okay, that were a few introduction information, and now let's dive into the webinar. In the beginning, we will look into key challenges in ICS environments and I will present you also 3 different critical infrastructure attacks. Then we will cover some basic steps to address or improve the security of ICS. Later on, we will examine how Cisco security solutions can be used in the story of improving the security posture of an OT environment. At the end, we will simulate a cyber attack against a simulated ICS, and we will use Cisco Cyber Vision to see what's going on and what has happened. And I promise you, there will be some fireworks at the end. Before we start with the solution, this is Cisco Cyber Vision, we need to identify the problem. Why we are talking about ICS OT security? Industrial control systems are the heart of critical infrastructure, and if we witness an attack against critical infrastructure, then maybe some lights could go out, or some goods could be damaged, or the worst case, maybe human life could be in danger. The damage that is caused after a critical infrastructure attack can be immense, so securing those systems is very important. But to do so, we are facing many challenges in the OT world. We have a huge list of legacy devices. The lifespan of the devices can be up to 30 years. A lot of times, patching is not an option. Can you imagine that you didn't patch your devices in IT for 20 years? I guess not. It's like you would connect this PC that you see on the slide to the internet today and hope that everything will go well. But besides legacy devices, also protocols are an issue. Almost every vendor has its own protocol, and the protocols were not designed with security in mind. If we see encrypted traffic in OT network, then most probably we have malware in our systems. Encrypting or not encrypting is actually today a hot topic in the OT world. The unsolved challenges that I mentioned give opportunity for hackers or attackers. Threats are therefore coming from different directions and different sources. Additionally, we started to speak about IoT and smart devices. Everything is going to be connected. The bridge between IT and OT is shrinking, and as we introduce new pathways into the world of OT, we should do this properly. Recently, we witnessed malware like WannaCry and NotPetya. The damage that was caused by WannaCry is estimated to be from 4 to 8 billions, and NotPetya's damage is estimated to be more than 10 billions. This is around one-fifth of 2018 GDP of Slovenia, which you can see on the slide. So if you're talking about the damage that was caused by malware in terms of GDP of a country, then we know that we have a huge problem there. On the right side, you can see the ransom message presented by NotPetya after the final stage. It is believed that the ransom was a cover-up. The purpose of NotPetya should be only disruption and destruction. But recently, we saw someone moving bitcoins from the initial address, and so actually no one knows if this is again a cover-up or the attackers are actually moving bitcoins in order to exfiltrate the money. Additionally, the business model of the attacker changed. Due to the popularity of cryptocurrency like Bitcoin, Zcash, or Monero, transactions are just a YouTube video away. Encryption, ransomware, and cryptocurrency go hand in hand. The driver is, of course, making money. As we will see more connections from the IT to the OT, we will also witness more IT malware that will affect operations and industrial control system. But let's not forget about state interest and cyber warfare. Most common about this kind of threats is that they are more sophisticated, harder to attack, and the goals of the attackers are different from regular cyber attacks. When I will talk about ICS tailored malware, I mean malware that knows the industrial process, that knows what to change to cause damage. As we see in practice, this is no more science fictions. We will address ICS tailored malware in 3 case studies in about a minute. But if you still don't believe me that unsolved challenges give opportunity, here are some examples of public disclosed breaches that happen in various industries. We've seen breaches in water supply, nuclear, pharmaceutical, healthcare, petrochemical, and the electrical power grid. And these were only the ones that were publicly disclosed because they were huge. And where in this story comes Cisco Cyber Vision into play, we will talk in detail about it further in the presentation, but just to give you a hint, we need to have a closer look into our ICS OT environment if we want to know that something fishy is going on. Now that we identified the problem and I gave you a hint of the solution, let's start at the beginning, since every story should have a beginning. The story of critical infrastructure attacks, as far as I know, starts with Aurora. In 2007, in Idaho National Laboratory, researchers demonstrated that critical infrastructure attacks are possible. They bought a diesel generator from an Alaska oil field for $300,000 and managed to destroy it. In the experiment, the researchers assumed that an attacker somehow gained access to protective relays. Protective relays are designed to continuously monitor for dangerous conditions. If the dangerous conditions are met, protective relays open circuit breakers and disconnect the electrical source from the electrical grid. In our case, this would be the diesel generator. In the attack simulation, the researchers reprogrammed the logic of the protective relays and caused an out-of-sync condition. But let's look at the video. You will see the generator first fighting against the power of the grid. Did you notice a hit? And another one. Already some parts are flying around from the shaft of the generator. We see another hit. And after a while, smoke starts to come out of the generator. And this is actually a very bad sign and indicates that the generator has been destroyed. So with this, With this result, a smoking and destroy generator, the researcher proved that few bytes of malicious code, real damage can be caused. It is believed that around the same time of the Aurora demonstration, Stuxnet was already in development. Without going much into geopolitical issue, Stuxnet was designed to delay the production of purified uranium that is used for nuclear weapons. A not so typical case for malware is that Stuxnet used 40 days to achieve its goals. So why should waste 40 days in one piece of malware? If the malware got discovered, you lost 40 days, and malware authors often use 10 day if they use a 0 day. So this is kind of unusual and also indicates the direction at which Stuxnet came from. But once Stuxnet is on the system, it infects project files of Siemens WinCC SCADA control software and replaces a key communication library of WinCC. When the malicious code is deployed on the PLC, an attack routine starts to execute. There were actually 2 attack routines discovered, but only one was used. In the attack routine, Stuxnet tries to overspeed the rotors of the centrifuges, and it was very effective in doing so because it destroyed almost 20% of the centrifuges. But as you remember, replacing a key communication library, he was playing the man-in-the-middle game and reporting a false-looking good feedback to the operators, and therefore the failures were harder to identify. Actually, a lot was written about Stuxnet, but it is still regarded as one of the most sophisticated malware ever created. Maybe Ralph Langer, that analyzed the Siemens parts of Stuxnet, described it best by saying, "The payload is rocket science." With that, he meant the part that is running on the PLC. Our next case study is about the Ukraine blackout saga. In 2015, a critical infrastructure attack was executed against 3 energy companies in the Ukraine. They used spear phishing as an attack vector with Office documents that had malicious macros. Once macros were enabled, Black Energy 3 was installed to the system. The attackers used then Black Energy 3 to harvest VPN credentials, and after having VPN access, they interacted directly with the SCADA and caused about 2,100 households to go dark for up to 6 hours. The operators then switched to manual operation because remote operation were not possible anymore, but they managed to save the day at the end. In 2016, in terms of capabilities, the game changed. Although the damage was not that high, as in the previous attack, the capabilities were. It is not known how the attacker got in. Maybe they didn't even leave the system. They use industrial or crash override as the final piece of malware that should affect electrical grid operation. But actually, it came with a flaw. The denial of service capability against Siemens C-Protect protective relays failed because of wrong implementation of byte conversion for IP addresses. The intent was, for example, to send malicious packets to this IP address that you see on the slide, but instead they were sent to this IP address. So because of this, the model didn't work. And the reason is not known. But nevertheless, the capabilities were scary. At the final stage, you didn't need to have someone that understands the industrial process. You need a skilled attacker that only places the malware at the right position, and of course executes it after that. Industrial or crash override was the first ICS-tailored malware to target electrical grid operations. The third case study is about malware that targeted a safety instrumented system, and the malware goes by the name Trisis or Triton. To be more precise, it was designed to target the TriConX safety instrumented system. As the name implies, SIS, in short, or a safety instrumented system, is meant for safety. They are monitoring for dangerous conditions, and if process parameter value exceeds the limits of normal process behavior, the sys attempts to bring the process back into a safe state or automatically perform a safe shutdown. It is believed that the aim of the attacker was to alter the safety conditions so that in case of process malfunctioning, the safety routine of the sys fails. Luckily, the attacker failed by manipulating the sys and caused process and operation shutdown, so the consequences of the attack were reduced to minimum, since after the shutdown, the attackers were quickly discovered. So with Trisis Triton, we conclude our case studies of ICS tailored malware, and let's look at the other part, the defense part. Whether we are talking about IT malware and ransomware, or we are talking about ICS tailored malware, we need to somehow address the security in OT. I really like Robert Emily's sliding scale of cybersecurity. We have 5 different stages that describe the value towards security versus the costs to implement and maintain the state of security. The security benefits decrease from left to right. The cost does increase. The last 2 stages are mostly not implemented, since they cost a lot and don't provide such benefits in terms of security. Offense is also highly questionable from a moral standpoint. So if properly implemented, the first 3 stages give high confidence, and here we are talking about architecture, passive defense, and active defense. Okay, here we're looking at a proper architecture where passive defense can be applied, because we can address architecture and passive defense together, since security devices and solutions come with these capabilities. However, when we have a flat network, then all the magic security tools won't help us. So the first thing to do is network segmentation. A popular model in OT is the Purdue model, or the Purdue reference model. The Purdue model has 5 zones. The zones between 0 and 2, which you can see on the slide, are referred to as the cell area zone. Zone 3 is the manufacturing zone, and zone 4 is referred to as the enterprise zone. The right approach to implement the Purdue model is to include DMZ between the enterprise zone and the manufacturing zone, as you can see also in the slide. It's actually the same concept as with the internet and the corporate network. So the Purdue model gives structure and helps us to implement architecture. This slide was actually taken from the presentation of Srinivas Teneti. I hope I pronounced the name correctly, and I apologize if I didn't. That was given at Cisco Live 2020 in Barcelona about security design for enabling Industry 4.0. So we can see also some Cisco devices at different levels, but we will talk about these devices in about a minute. If we want to mature in security, we need to talk about active defense. So we have architecture, passive defense, and then we come to active defense. With active defense, we're talking about people and processes. They provide security operations, the people. According to SANS, the active defense model has 4 major pillars placed in a cycle. But for me, most importantly is this one, which is asset identification and network security monitoring. Once you know what your assets are, you identify the communication patterns between them, and then you can define what's normal and what's abnormal behavior. So if we want to start, we should start here, and of course other pillars are also important, but we should start with here. And active defense, we also use threat models. One which is quite popular is the cyber kill chain. Maybe you heard of the cyber kill chain, but here in ICS, we have, of course, an ICS cyber kill chain. The difference is that we have 2 stages in the ICS version. To summarize, the first stage is about getting in and preparing the attack. The second one is executing the attack. The ICS cyber kill chain can help us actually when we're trying to define at which stage attackers are and what will be the next move. So apart from this model, we have also the MITRE ATT&CK for ICS. In the IT world, the MITRE ATT&CK framework recently gained a lot of interest. In the framework, we were talking about techniques and tactics that were used by the attackers in publicly disclosed cyber breaches. But guess what? For industrial control systems, we have MITRE ATT&CK for ICS. The same concept applies. We have tactics and techniques, but these tactics and techniques were from known and disclosed breaches in the ICS world. We mentioned actually three in these presentations, three breaches. For example, the Triton malware can reprogram the sys logic. Here we are talking about the technique named modify control logic, which you can see here under the tactic impair process control, and also here under the tactic inhibit response function. MITRE ATT&CK for ICS was published not long ago, and I believe it will gain a lot of interest and become over the year even better. In our NIL Security Operations Center, we are using both the MITRE ATT&CK for IT and for ICS because the model gives us a good framework where we can establish the security posture of a company and also monitor the improvements. Okay, so we talked about architecture, passive defense, and active defense. Also, these models have been mentioned. With Cisco, we have many options to establish proper architecture, apply passive defense, and also kickstart active defense. The first thing to mention here are Cisco Industrial Ethernet switches, which are actually core components to establish proper architecture and passive defense. Then we have Cisco Firepower next generation firewall, which can be used to enhance our capabilities even further to protect our perimeter. With Cisco ISE, we have the capabilities to enable OT and IT security teams to create and enforce access-level security policies. In fact, my colleagues from Consul Sweden wrote an excellent white paper about network segmentation of industrial control systems with Cisco ISE and TrustSec SGT technology. They proposed a solution where you could do network segmentation without changing the OT endpoint configuration. And this is important because introducing segmentation can be extremely complicated, and the necessary changes have a very big impact on the network. In their solution, however, they also included Cisco Industrial Network Director, which is a tool that is used for in the OT stuff and can discover OT endpoints and, of course, also easily manage network equipment. One more solution to mention before we go to Cisco Cyber Vision and Cisco StealthWatch that can be used in the IT world. As well, it can be used in the OT world. StealthWatch provides network visibility, and it's based actually on NetFlow. It applies advanced security analytics, and therefore it can detect and respond to threats in real time. So, Cisco Cyber Vision. I talked about Cisco Cyber Vision in terms of active defense because for me it's the go-to tool for doing active defense in an OT network. Due to deep packet inspection, it deciphers industrial protocols and gives full visibility into the traffic. The solution is fully passive. This is really important in the OT world because we don't want to interrupt network flows because this could cause operation shutdown. In general, we could say that Cisco Cyber Vision has two parts. The center, which is the software and can come as an appliance or as on a virtual machine, and then we have the sensor. The sensor does the deep packet inspection and sends metadata of traffic to the center. We have different hardware sensors, but the most lightweight sensor is most probably the IC3000 industrial compute unit. However, it is expected that in the near future, any device that is able to run Cisco IOX and has an SSD storage unit could act as a sensor, which is actually good news for all that have some Cisco equipment already in position. We have more options to deploy Cisco Cyber Vision in our environment. If we have a Cisco switch that is capable to run the sensor software, we need to just connect it to the Cyber Vision Center. In the case when we have other network equipment, a span or mirror port needs to be connected to the hardware sensor. And also there is a tap setup, which is possible if the hardware has no such capabilities. Okay, enough of dry talking, let's see Cisco Cyber Vision in action. But before we going into the demo, let me introduce a simulated ICS environment that we will monitor with Cisco Cyber Vision. The simulation was created by the researchers from the Georgia Institute of Technology and it's called in short GRFIX. It is based on previous work in the field of process control. To be more precise, it is based on a simplified version of a process control problem that was introduced by the Eastman Chemical Company. You can see here the draft of the process on the right side of the slide. So keep in mind, by designing a control system for this process, the reactor pressure here must be kept at safe level, and we are trying to maximize the efficiency of the product and minimize the purge that's going on. So also here we can see the architecture of this simulation, and this part refers to this simulation. Of course, we have a PLC and we also have an HMI. So this HMI is used by the OT engineers to control the process and to react at different scenarios. And the PLC is used for controlling the input-output devices. So let's look at Cisco Cyber Vision here. Okay, this is a nice dashboard that we have, but let's go straight to a preset. I already prepared a preset that's called demo. And let's switch to Map Expert. The first thing you will notice is this somehow applies to the slide that I show you about the architecture of the ICS environment. We have the physical simulation, we have a PLC, and we have an HMI. I also introduce into the system an engineering workstation. This engineering workstation is used for updating the program on the PLC. So this is, let's say, a simple environment. I guess you have more of an environment like this. It's more complicated, but still manageable. But in Cisco Cyber Vision, we have the notion of presets where you can define what you want to see. For example, if you want to monitor just one aspect of this system, you can do so. You can see engineering workstation, and we can see a chemical process. And here we can see some communication going on between the engineering workstation and a controller. Actually, a program download. This means that the engineering workstation updated the PLC program. So just remember, the same concept applies to small environments as to large environment. For example, in this demo preset, I didn't want to see broadcast, low volume, and multicast traffic. So I just disabled this to see in my preset. In fact, let's create a baseline out of this and call it baseline 0. Let's go check it out. And I will remove this line and say notify Security Operations Center. Why is this? Because I want to be notified if the engineering workstation updates a PLC program. So let's go back to our preset. And here is the simulation that's running. I need to connect back again. You can see the simulation running and the pressure is changing. We have a purge and we have a product. Then we have an HMI, which I said the OT engineers monitor the process, and we have a PLC. The PLC is basically an Ubuntu server that's running the OpenPLC software. And then we have the attacker. let's simulate that the attacker is actually an external contractor that will connect to the manufacturing network. So we will do this by assigning an IP address to the attacker, and we will just ping the engineering workstation. And let's see what happens here in Cisco Cyber Vision. So the engineering workstation is actually dual based. It has two interfaces. One interface is used for accessing the PLC in order to control the process, and one interface is in the manufacturing network. So here's our new device that already appeared, which is the attacker, and he did a ping and of course an ARP scan to identify the right MAC address where the manufacturing interface is. So let's see what happens if the attacker does an Nmap scan of the engineering workstation. So he tries to identify what services are open in order to exploit it. He identified that the file sharing SMB service is open. And let's see what changed in Cisco Cyber Vision here. You can see the line changed from blue to red, and we identified a port scan activity. This was automatically identified by Cisco Cyber Vision. In fact, let's look at the baseline. We can see that this behavior deviates from our baseline. We have a new device and we have this new activity. So these are actually at least two events that we will see here, two difference in the baseline, for example, and let's look at the high severity events. All these events indicate some malicious behavior, and this would be treated or examined by a security personnel like SOT security analyst and so on. So basically you can do analysis of the events in Cisco Cyber Vision, but also you can forward these events to security solutions like a CM. So let's go back here again. So the attacker identified this service to be opened, and what he does next is to try to identify what version is running as the service. So he identified that SMB version 1 is running. Actually, I forgot to mention that the malware WannaCry and NotPetya used a vulnerability in SMB version 1.0, and actually they used an exploit from that was developed by the NSA, which is called Eternal Blue, and was leaked by the shadow brokers. So our attacker here will use the same exploit, and for this we will use Metasploit framework. We already set up some conditions. Let's just check again if everything is going to work, and let's try to run the exploit. We can say that the exploit already said that host is likely vulnerable to this vulnerability, and the exploit was successful. We have a interpreter session, and let's identify at which user we are running on the engineering workstation. We are system, so this means we have basically all the privileges that we need to have to exploit further. So what you see here in Cisco Cyber Vision is another device, because the payload contained a host name and was randomly chosen. So you can see two devices. And if we look at the activity between the engineering workstation and the new device, we will notice first that from the new device a lot of SMB connections happened, and at the end, the engineering workstation connected to port 4444 back to the new device, which is very, very suspicious. So the attacker aim is to make a physical impact on the process, and most probably try to overpressure the tank and make it explode. So to do this, he needs to somehow gain access to the PLC. So what he will do is a pivot. He will forward local port 8081 to the PLC. And let's move to, let's say, a more nicer version of the attacker, which is our RDP session. And let's connect to this pivoted port. You can see an OpenPLC server running. In reality, this is kind of different because if you have an engineering workstation, you will notice a program download if the engineer tries to modify the PLC. In our case, we only see a HTTP session because OpenPLC is based like this. You have a web server and you upload the PLC program, and then this program is internally deployed by the PLC. So the attacker got access to the OpenPLC server, and he came prepared with a malicious program, and he will do upload the PLC program. We don't see any errors, some warnings, but this means the program has been modified. And in the simulation, this will mean that the pressure will constantly rising until it reaches a critical point and this tank will be exploded. But let's look at Cisco Cyber Vision at the activity that happened. Okay, I don't fight it because we are doing this live. But nevertheless, let's look at the baseline. So what we see here is these two new devices which present the attacker. We see some new activity towards the engineering workstation, and then we see a connection from the engineering workstation to the PLC. So these are all indication of a breach and a successful attack. And if you look at the pressure, it's still rising. But since we don't have time, I will just present you the video and hope that you believe me on that, on the word. So I will fast forward here. You can see the pressure rising, still rising and rising, and almost we will hit a critical point. Just a few seconds. And you can see the explosion. So the aim of the attacker, or the goal of the attacker, was accomplished. And how we could prevent such a disaster with Cisco Cyber Vision? The first thing, or the first indicator, was a new device that appeared. Then the new device did a port scan of the engineering workstation. Then the new device and the new activity presented a baseline deviation, or let's say an anomaly in our OT network. I showed you also a lot of SMB connections between the new device and the engineering workstation. At the end, we saw the engineering workstation connecting to port 4444 of the new device. And the last one, again, a baseline deviation. A PLC download happened that was initiated by the engineering workstation. As you remember, we removed the activity from the baseline as you wanted that on a PLC program change, someone gets a notification. Just to mention here, we saw that tank exploding in the video, but we kind of like to disconnect from reality if we are watching movies. So this is serious stuff. Imagine the cost for a company after a tank explodes in reality. Imagine that the damage that is caused and the danger that the people are exposed to working there. What if this is not only one tank, but are 100 or 1,000 tanks. Imagine a coordinated attack against these 1,000 tanks. My intention is not to scare you, but we are talking here about serious stuff and not about only few computers that could go offline. Let's wrap up the webinar. We saw that critical infrastructure attacks are becoming a reality. Whether it is IT malware or ICS tailored malware, industrial control systems and OT environments had and also will experience attacks from different directions. Due to the tendency to interconnect IT and OT environments and also other issues we talked about, now it's the right time to address the security. We should address the security in the right order, which is first architecture and passive defense, then active defense. In this presentation, we saw active defense with Cisco Cyber Vision and how we could prevent this disaster at different stages of the attack. I think that we all agree that we want to see an environment-friendly, a more safer, and also people-friendly industry. Today, we address some aspects that contribute to a more safer industrial control system. So with this thought, I'm concluding the presentation and invite you to the Q&A part. Let's look at some questions here. So one attendee is saying that we called layer 3.5 between DMZ and corporate network. Yes, this is basically the same thing, but a different terminology. And we have another question regarding IoT. Since you are referring a lot of PLC devices that are basically less used, that for example, LoRa, Wi-Fi, Bluetooth, Arduino, RPR-based devices with connectivity to server, you should address this method also. This was a question. Yes, of course, IoT devices are also very important, but in this presentation, we somehow focused to the critical infrastructure part. But also these devices are important, and of course, this could be also monitored with Cisco Cyber Vision. Can you give some info about Stuxnet? A lot was written about Stuxnet, and most probably there will be more things that will be discovered about Stuxnet because it's quite complex and huge. There is another one. How many Cyber Vision sensors do you need in an OT environment? From Charles. It totally depends on the architecture and the size of the OT environment. If you have, for example, like you have in the electrical grid substations at different geographical locations, then you would place the sensor at every substation. The goal is to catch the activity that happens in the OT network. So it depends on the architecture, but we are aiming to reach the goal to catch as much activity as possible here. Since we are running late on time here, I would like to conclude the Q&A part. If you have additional questions, please be so free and email me. I would be glad to answer them. So, okay. Just email me if you have any questions. That's all what I wanted to say or discuss today. I hope you enjoyed the webinar as I did. I wish you a pleasant rest of the day. Take care, stay safe and healthy, and thank you for your attention. Bye.